Good morning, good afternoon, good evening, everybody who's joining in on this webinar today. My name is Tim Chan. I'm from the Methanol Institute. I'll be giving a short introduction to the webinar, which is focusing on biomethanol today. We have two presenters from NextChem and Södra who'll be speaking about their own business with biomethanol in two different countries in the European Union, one in Italy and one in Sweden. So just as a start, we would like to thank everybody who's participating on the webinar today. Beyond that, there's a couple of things that we need to take note for housekeeping. Everybody's on mute if you're a participant, so don't worry about muting yourself or that we can hear you in the background. One thing to note is that you can raise your questions in the control panel that you should see on your screen right now. If you see your control panel, it should have a drop-down menu for questions. If you click on the drop-down menu, you should be able to type in your questions down there. We will be having the Q&A at the end of the two presentations, and as much as possible, we'll try to answer most of your questions. Beyond just questions, there is a tab on your control panel which should say handouts. In that handouts tab, if you click on the drop-down menu, you should be able to download today's slide deck for your future reference. So without further ado, I'll just give a short introduction and say a few words about Methanol Institute. Once again, I'm Tim Chan. I'm based in Singapore. I'm the Manager for Government Relations and Business Development within the Methanol Institute. MI, or Methanol Institute, was founded in 1989. We've had about 30 years of history right now as a global trade association for the methanol industry. And we have 4 offices around the world, which you can contact us at. They are Washington, DC, Brussels, Beijing, and Singapore. So these are our members. MI operates on a tiered membership basis with the biggest methanol producers on the highest tiers, and it trickles all the way down. Our members are methanol producers, distributors, technology providers, and even companies that have developed their own novel and innovative solution that utilizes methanol as a fuel. And they are usually in tier 4. So you might see some companies down there that you recognize. And if you don't, and you have any questions about some of our members, do feel free to reach out to me after this webinar, and I could go through or give you a quick introduction to some of the members quickly. Just to give a short, brief overview about how the work is divided within MI, we focus on 4 key areas, and they're divided into 4 work streams headed by 4 committees. We have the Marine Fuels Committee, which focuses on the promotion of methanol as a clean burning marine fuel. We have the Product Stewardship Committee, which focuses on promoting the best guidelines for handling of methanol as a product. There is the Market Development Committee, which looks into more innovative applications of methanol in different areas such as fuel cells, industrial boilers, cook stoves, as we see the market growing in some of these segments. And the last committee that we have is the Global Fuel Blending Committee, which focuses on methanol as a fuel for land transportation. So to just quickly give a quick introduction to MI and what we believe in, MI supports the values that are enshrined in the Paris Agreement and the UN SDG, Sustainable Development Goals. We do this by acknowledging the need for greater alignment between the public and private spheres to foster increased sustainability for environments, economies, and societies. Part of our work, or a big part of our work, really is to advocate for the recognition of alternative fuels. And we do this by engaging with government stakeholders on policies that could level the playing field for alternative fuels such as biomethanol. MI also supports the technological developments that enable the sustainable production of methanol, which includes renewable and biomethanol production. We do this because it lowers greenhouse gas emissions, which in today's current climate is very timely and is a hot topic right now, by utilizing carbon capture. processes such as biomethanol by using waste as a feedstock also increases or diversifies waste management by diverting waste from landfills and incinerators and using waste as a feedstock for biomethanol production. In doing so, this increases the value of waste, and in our economy as we know it right now, something that is of value is rewarded, something that is of value is preserved and used more wisely. And as such, giving value to waste as a feedstock for biomethanol production enhances the way that we treat waste in our societies and economies, and it leads to more sustainable outcomes. Just as a quick introduction, methanol is currently largely produced from natural gas, but it is a good starting point for a transition to a clean and sustainable future where methanol can be used as a fuel for marine and land transport, as well as feedstock for petrochemical production. And all of this comes together or ties in together to bolster or support the circular economy as we know it, or the circular economy that we're trying to build for the future. Just quick overview on a piece of legislation, since we touched upon MI's role in advocating for a level playing field with government stakeholders for alternative fuels. And I think it's good to raise the EU RED2, the Renewable Energy Directive 2, because two of our presenters today operate within the European Union and operate within the framework of European laws and legislation. So the Renewable Energy Directive 2 has a mandate that dictates that the level of ambition for renewable transport fuels should be at 10% of the total consumption within the EU bloc by 2020, which is this year. And this level of ambition is slated to rise all the way up to 14% by 2030. This is a good development in the way that it recognizes fuel that are produced from alternative sources that can be more renewable and sustainable. But we cannot forget that this is still a complex piece of document that requires more looking into to understand what it really entails. So as the slide says, the devil's in the details. Just to raise a couple of points that can be derived from the language in the EU RED2. It sets certain caps and certain minimum thresholds for, say, the inclusion of renewable fuel, but also caps on what renewable or sustainable feedstocks can be used. So if you're looking at food or feed crops, they're capped at 7% or at 2020 levels, which is this year. So whichever is lower, 7% or 2020 levels, that will be the cap. High ILUC risk feedstocks, ILUC being intended land use change, will be reduced to 0%. And feedstocks or waste feedstocks that are included in Annex 9 Part B, which includes a number, but not too many, of waste feedstocks, such as used cooking oil, will be kept at 1.7%. The minimum share of advanced biofuels, though, would rise to 3.5% throughout the EU. And if you look into the EU RED2 and Annex 9 Part A, you'd find the list of feedstocks that qualify for advanced biofuels. And all these different criteria in the EU legislation has consequences for the methanol markets. For one, conventional methanol volume can be at risk due to the potential lower share of conventional biodiesel and other alternative fuels that derive their feedstocks from food or feed crops or high ILUC risk feedstocks. So there is a risk there that conventional methanol demand might be lower due to these trickle-down effects. But it's not all negative. Waste-based biomethanol benefits from advanced minimum sub-targets, which is at 3.5%, and 3.5% being 3.5% of the total EU consumption for transport fuel should come from waste feedstocks that are listed in Annex 9 Part A. one thing to note, e-methanol is also not considered an advanced renewable fuel, which is something that different groups are advocating for. And this is still a work in progress, and we hope to see that change in time to come. So that wraps up my introduction for today. I'll give the time on to my speakers who will introduce themselves, as well as their various projects in Sweden and Italy, as well as their experience with producing biomethanol. So the first speaker to present today would be Giacomo Rispoli from NextChem. And Giacomo, I'll pass on the time to you.
Good afternoon, everybody. I thank you very much for the kind invitation for this presentation. And my presentation is based on a different approach to produce biomethanol, starting from waste and relying on technologies that our gasification technology. Okay, if we go ahead with presentation, okay, I divided in three parts. First, how to explain how the technology works, then how we can, from the waste, produce methanol, and then my conclusion. Going ahead, in this slide, you can see that our system is an important application of a circular economy. Because we can capture the carbon and hydrogen contained in the waste, and we can give them a second chance of life. How we do this? First of all, we produce a syngas in a partial oxidation of the waste, and once the syngas is produced, you can see that there is a variety of options of different routes that we already studied, and some of these that I'm going to present are under engineering phase. Hydrogen, methanol, etc., etc. Then going ahead, okay, it is the huge why our interest in the waste, because in the world there is a large availability of waste. In 2050 is expected to reach 3.5 billion tons of waste, which means an enormous amount of carbon and hydrogen available. If you look at the composition, the average composition, where we expect from 30 to 50% of the carbon contained in the waste, and from 5 to 10% as hydrogen. This means that there is a sort of feedstock which is available every day, that already there is a logistics in place which works every day. And so it is very easy to intercept this supply chain and to have a waste for the plants. Our technology is, I mentioned before, the partial gasification. It is a robust technology, and the first units were built in Japan at the beginning of 2000. And so now there are more than 20 years of operating experience, and we started from that technology, and we adapt the technology to the different routes that now we are following to produce many products. Anyway, it is all these references to show you that the technology is very well industrial proven. Going ahead. Okay, this is in this slide you can see the principle of how this unit works, and there is a waste. The waste is with this heat content is put inside the reactor. The reactor works in the range from 1600 to 1200 degrees C. We put in the reactor oxygen to create the syngas reaction, and also we put a little bit of methane in order to maintain a constant profile temperature. From the bottom, we generate a liquid inert that then is vitrified once is in touch with water, and so we generate small spheres of such a dimension, completely inert, that can be used for landfilling. And if we go to the top, in the top we generate the syngas produced, and now the syngas is submitted at a different level of cleaning and purification in order that we can adapt other catalytic processes along the line. In the first purification, there is a quench, then there is an acid scrubber, and then alkaline scrubber. Let me emphasize that all the chemical reactions take place in reduced atmosphere. This means that we don't have production of NOx, we don't have production of dioxins, furanes, etc., because we are in the reduced atmosphere. Then after this cleaning, we go with two electrostatic precipitators in order to retain any kind of particles, and then the syngas is ready to go to be submitted for different purification schemes. But just to summarize what I said, it is important that waste, we don't require any special treatment of the waste. We can admit any kind of urban waste. No problem with chlorine content. Overall plant reliability is very important, and so we have certain gasifiers in parallel in order to guarantee 24/7 the operation of such a unit. No flash ash production, no dioxins, as I said, deep abatement of contaminants, and then the syngas is in the end rich in hydrogen and carbon monoxide. And more or less there is half of hydrogen in volume percent and half of carbon oxide. Going ahead, okay, just to say, once the gas, the clean gas, then the clean gas, we have removed the residual with chlorhydric acid. Then there is hydrolysis of COS and ACN, HG removal, H2S removal, deep polishing of H2S, and now the gas is ready to go ahead for the catalytic conversion. Okay, this is the scheme that I presented from gasification, cleaning with water, acid, then purification, chemical purifications, and then all the what we can produce. Now we are going to concentrate on methanol, but there are a lot of products that once you have a syngas, you can generate. Of course, starting from the waste. Waste to methanol approach. Once we produce methanol, of course, with methanol we can do a lot of things, because we can use biomethanols for resins in the plastics, we can use in FAME for biodiesel, we can use to produce NTBE and then gasoline blending, or it is very, very important, we can use bunker oil, and that can be, let me say, the new fuel for the shipping industry if the shipping industry has to reach very stringent CO2 reductions going in the pathway towards 2050. And so there are many possibilities, many field of application of methanol. Going ahead. Okay, an important thing of such a scheme is it is the CO2 benefit, because when in the, let me say, in the existing case, normally waste are incinerated to produce power, and then they produce CO2. At the same time, if you have to produce methanol, you have to start from natural gas and you produce CO2. But if we combine all together, we save in reality the waste to energy plant, no longer needed to have these incinerators. We have just one complex that can produce chemicals, but at the same time you are able to get rid of the waste that you generated. And this means there is a significant CO2 reduction. Then later on I will give you some data on the business case I presented. In this slide, just to tell you more or less the cost of the unit, let me say the two important things. So the cost are the capex, because of course you have to invest. We need to invest a significant capex, but also there is power consumption to produce oxygen starting from air distillation. These are for the cost, the operation cost of the air separation unit. And then there is a benefits in terms of CO2 savings, and so the cost of the CO2 will be reduced, and also what we call waste gate fee. When in Italy or in Europe we treat waste, we receive money from government, because and so it is, we call this gate fee, because it is a negative cost of the raw material. Going ahead. Okay, this is it is just to discuss about real case. Our idea is not just an idea. Our idea is a real project, the first project in the world that today is in the designing phase in Livorno refinery. Livorno refinery is one of the refineries belonging to any group, and this unit that you can see the tanks and then the area of the gasification. And on this part there is the rest of the refinery. It is a medium-sized refinery. The engineering schedule of this project will be completed by this summer in August. That is the raw material that we are studying in our case are RDF, and also we call plastics, but non-recyclable plastics. There is a mix, more or less 20–30% of plastics, and the rest is RDF. Then go to the production scale. Go ahead. Okay, in this slide you can see the different sections of the unit. In the first part we have 3 gasifiers in parallel to produce per year. We have the feed capacity is 200,000 tons per year of feedstock. And then with 200,000 tons, we achieve more or less a little bit more than 100,000 tons of methanol. The second, then there is the purification that I mentioned before, conditioning, and once we have the syngas, we go in the methanol production. With the catalyst, we have options, and in any case, we are proposing Jones Matthey technology. And going ahead, okay, it is important once the syngas is produced to achieve this important parameter for the methanol reaction. We need to have 2.1. This means that we have to increase the hydrogen concentration in the syngas, and in order to do this, we do a little bit of a shift reaction. We remove the CO2 produced. In such a way, we achieve the data that we need before going in the reactor, in the methanol reactor. Okay, it is again, it is the scheme, compression, and then methanol distillation and methanol production. Going ahead, in this case, I just, to summarize, I put all the number that everybody can use in order to develop its own economics of the project. As I said before, this is the feedstock, a little bit less, 200,000 tons per year of this such kind of feedstock. Then we put power. We need the power for air separation unit. We need a little bit of daily water for also shift conversion. We need a little bit of natural gas to maintain constant the temperature in the gasifier, depending on the heat value that there is in the feedstock. Then there is the CO2 that we are going to generate, the methanol that we produce. It is more than 100,000 tons per year, more or less. With 2 tons of waste, I produce 1 ton of methanol. And then an important data, it is the CO2 that we save in this process. 1 methanol is generated and you use as fuel, you generate CO2, even though it is inorganic provenience or from waste. But what is important is that during the conventional this process, we save all this quantity of CO2 when it is compared with the conventional scheme of production of methanol. We generate also a little bit of inerts for landfilling. We generate a little bit of sulfur contained and also part of the slag. And then it is the CO2 that is generated by the utilities that we make use. But another important figure that I would like to stress is the cost of production of the methanol. In such a case, is less than 200 euro per ton. So it is a very, very low cost. Of course, we achieve this cost because also we receive this gate fee in Italy, and this gate fee for the waste is in the range of 100-120 euro per tons. Going to my conclusions, let me say that this technology is absolutely representing only a competitive process, performing a low carbon footprint. It is very, very important because if we have to reduce the carbon footprint, this technology is in this direction. Then another important thing, waste represents a valid source in the world of carbon and chemicals. And so I think that the technology that we present, that we propose, can be a real alternative to the use to feed incinerators. So the incineration process can become a very obsolete process compared with this new technology based on the principle of circular economy. And then it is another important thing, okay, fits completely with the circular economy concept, and then we also the economics that we are analyzing and that we have for this project in Livorno refinery, very, very good economics. We didn't receive any kind of subsidies for this project. It is a project that is sustainable not only for the environment, but this approach is sustainable also for the economic point of view. Thank you very much, everybody.
Thanks, Giacomo. So next up, we have Victor from Södra, who will be giving his presentation about their biomethanol production. Let me just pass his controls to him. And Victor,
yeah,
you have controls right now.
Yeah, perfect. Hi, everyone, and thank you again, Tim, for being invited to this and giving Södra the possibility of sharing our experience of putting a new product to the market. The time is quite limited, so it's difficult to deep dive into anything here right now. So I will just briefly went through the agenda. If there are any questions or anything you want to ask, do that here, or send me an email or give me a call after the webinar. Feel free to do that. So a little bit information about Södra as a company, because as Tim mentioned earlier, according to the RED directive and Annex 9A, forestry residues is a part of the acceptable feedstocks. So I think it's good to get some knowledge about the forest company and Södra. A little bit about our new strategy, which was approved a couple of months ago, and more information about Södra Cell bioproducts, where I'm located, and our product portfolio. And of course, more information about our biomethanol. Now Tim has talked a little bit about directives and regulations, so I will probably not deep dive into that. Maybe some examples on how we have handled it here in Sweden. So Södra, everything we do is based on trees, and we say that we create long-term value not only for our 52,000 members, but also for Sweden in general, by being a major exporter of high-grade pulp and sawn timber. And I also think it's important here to understand that Södra is an economic association. With that I mean that our members are the owner of the company, but at the same time they are the suppliers of the raw material to our industries. And we believe we have a raw material that is renewable, recyclable and biodegradable. So we think that the forest industries plays a crucial role in the transition to a more green society and a sustainable future. So we hope to be able to show how a modern forest company can act out there. Just some figures about Södra. So we have one of the largest sawmill operations here in Europe, and we are one of the biggest European suppliers of softwood sulfate pulp to the pulp market. And we also convert some hardwood into dissolving pulp. And dissolving pulp here, I mean textile pulp that goes into the textile industry. All of our 3 mills are fossil free, and we generate the surplus volumes of energy, which means we sell a lot of green electricity and district heating to the market. So the assignment for us as a company is, of course, to find markets for the raw material that our members supplies us with, but we also offer a lot of different services and advice to the members. Also business policies, and on a political level we can help them to get as much as possible for the forest. The company is divided into 3 different business areas. Södra Skog is the face towards our members, I would say. So they are the one who purchase the forest from our members and also deliver them to the industries. And then we have the second one is Södra Wood, where we produce sawn timber and cross-laminated timber as well, which can be used for high-rise timber buildings. Here we also produce some side streams. With that I mean different kinds of pellets, wood shavings and other energy products. And the third one is Södra Cell, where I'm located. And this is our 3 pulp mills, which are located here in the southern part of Sweden. We are one of the leading producers of market pulp, where softwood sulfate pulp accounts for most of the production volume. And in one of our mill we produce dissolving pulp, as mentioned. So the core values within our organization and how we act against suppliers, customers, members or investment is that a long-term approach is really important for us. We have something we call the eco cycle here in Södra, which means by building value generating relationships we are taking a long-term approach, and by having a long-term approach we believe we create value generating relationships as well. So this is really important for everything we do. A couple of months ago there was a new corporate strategy accepted. It's about profitable and sustainable growth in an ever-changing world. The background to that is that there are many different kinds of trends out there right now, and many organizations and the society in general, I would say, moving towards more renewable products, and that is maybe the strongest trend, I would say, and where we hope to be able to put new products to the market, so we are able to make the transportations a bit more sustainable. But it's also about circular economy, where we last year launched a solution to recycle textile waste and use it for production of new dissolving pulp. But there are, of course, other trends as well: society, moving towards automation, digitalization, connectivity, and demographic and geopolitical changes as well. But increased focus on the sustainability and how to reduce the climate impact is, of course, topics that we see. And all this resulted in a new strategy, and of course this will affect our industry, many industries out there. There are many opportunities, we can definitely see that, and many organizations and companies want access to the forest as a raw material. But there are challenges, of course, also. Could be legal reasons, or it could be due to spruce bark beetles out there in the forest who harm the forest and make the availability of good raw material less. See if change the page. So this is the grounding in our new strategy. We call it 2025 plus here. So the financial targets will be valid until 2025, but then we have some group-wide targets, sustainability, for example, that will apply for a longer time than that. But it's about creating a profitable and a sustainable growth. And we think we can do that by, of course, develop our existing businesses and products, but also by putting even more focus on innovations, resource efficiency, and get even more market orientated and customer orientated. And there are many projects going on within Södra, and there will probably occur a lot of new ones that support this road and this new strategy. We have a joint venture in Norway together with Statkraft, where we look at the possibility of creating a liquid biofuel from forest biomass. We have an ownership in Sunpine. Sunpine produce HVO from a crude tallow, which is a part of our product portfolio. And there is we also work quite closely with KLM regarding how to produce a jet fuel from forest biomass as well. So there are many projects going on out there. So this new strategy and new projects and potential new products from our industries resulted in a decision half a year ago to create a new product area. We call it Södra Cell Bioproducts. We are responsible for the dissolving pulp, and also for the side streams from the pulp mills. So we can separate it and call it liquids. This is a way of having an organization ready for new innovation that can come up from our industries as well. And the portfolio currently consists of crude tall oil and turpentine, which we've been handling for many years. And now we also have our new product, the Bio-methanol, of course. The plant has now been up and running for a couple of months, and we get better each day to run the process, and the quality gets better and better each day. So we are able to produce a little bit more than 5,000 tons biomethanol per year. So we will now evaluate how the processes work, but it's not a secret that we have two other pulp mills as well, where this technology can be suitable as well. So there are possibilities of increasing the capacity. We call this product the biomethanol. It's a way of refueling the future. They said it before, but the areas of use are endless almost. You can put it into the biodiesel production, of course, as a pure biofuel, M100. It can be used as a drop-in fuel in gas line. It can be used within the marine as a bunker fuel, of course, and also as a broad platform chemical and into the fragrance and flavor industry. The product we have is certificated according to ISCC, where the greenhouse gas reduction with our biomethanol is up to 99%, which is exceptional high. So it's an easy way to reduce the climate impact if you can deliver these kind of products to the market. So the process looks like this. So it's a part of the normal flow within a pulp mill. What we do is that the wood chips are, of course, cooked with chemicals to separate the wood into its constituents. And methanol is created when the wood and the chemicals react. And after the cooking, the chemicals and other residues are washed out from the pulp and form something called black liquor, whose water content then is reduced by evaporation. What remains is a condensate of methanol, turpentine, and different sulfur compounds. And the condensate is then cleaned to be reused in the mill, and then raw methanol is created. Normally, this raw methanol is burned and used for energy and heat within the pulp mill. But what we now can do is that we pull this stream out and purify it into a commercial grade methanol. So it's about resource efficiency. And many has tried to do this, but never succeeded to get this kind of quality. So we are really, really proud of this innovation. Tim talked a little bit about this because there are probably many people out there who's interested in the pricing of the biomethanol. We'll not deep dive into that here, but there are, of course, the Paris Agreement and different regulations and directives here in Europe who can affect this. And the Renewable Directive Energy 2 is a game setter for this. But still, every nation within Europe is allowed to put their own targets and directives and regulations to support this overall regulations. So you need to deep dive into every nation to get an understanding of the pricing. But of course, there could be tax avoidance, for example. There could be different kinds of subsidies or tickets. In Sweden, and we have a quota system where all the refineries put some pressure on them that 2020, this year, they need to reduce the greenhouse gas emissions by 21% when it comes to diesel and 4.2% when it comes to gasoline. So there are many mechanisms behind this, but we won't deep dive into that here. I think that's good for me. I hope you enjoyed the presentation, and I let the word over to Tim again here.
Thanks, Victor. So now we'll move on to the Q&A portion of today's webinar. I guess I'll start off first with Victor, since you were the last to present. You touched upon quickly about regulations. And I think when I started my presentation earlier, we spoke about the Paris Agreement, the EU RED 2, which are really very broad pieces of legislation and documents that, as you mentioned, there is some room for maneuver for individual states. And as I know, in Sweden in 2018, your government has passed the Climate Act, one of the few countries around the world that actually has a climate change legislation. How has that impacted or benefited Södra in that way? And specifically for today's context, how has that helped with producing biomethanol?
Currently, now we're in an early step in this, so our product has not been out there on the market for that long time. But of course, if you look at the biodiesel production, there are initiatives that actually supports a green or a renewable or a biomethanol within the production, because you can avoid different taxes. So of course that has been a good initiative to make the investment decision.
Sounds good. Giacomo, if you could just unmute yourself. I have a couple of questions. We have actually quite a few questions from the audience, and I'll have to quickly go through some of the key ones and probably try to group some of them up according to themes. But if you can unmute yourself, there are a couple of questions directed at NextChem. And firstly, one of which is, what is the carbon footprint of producing biomethanol from the NextChem process, or more specifically, what is the carbon footprint of the Livorno refinery production of biomethanol? Could you give us a quick idea of that? Giacomo, I think you might have to unmute yourself. Okay, well, while Giacomo is trying to figure out his mic, there we have him. Okay.
Sorry, you said what is the carbon footprint for our Livorno projects?
Yes.
In our Livorno projects, I think that we just are completing the LCA of this scheme with the Milan University, the Polytechnic of Milan, and we achieve more or less 80% of CO2 reduction when we compare our biomethanol with the conventional methanol. So in terms of it is very significant looking at the whole LCA. It is 80%, 80.
Sure. So one thing that I wanted to ask was that, and I think this was also reflected in some of the some of the questions that the audience has posted towards NextChem, is the gate fee that you mentioned seems to be very significant in making this business look economical or feasible from your presentation. Do you think that similar situations are present in other countries? For example, if you were to produce biomethanol from waste using NextChem's processes in a different country, would you be able to still receive a gate fee from, say, that municipality or the company that's handling waste in that region?
Look, looking at European market, we compare the data that we have in Italy, which is 120 euro per tons that we receive from municipalities. In France, we have a little bit lower in France and Spain. In Britain, we have more or less the same data, and so that is the range. But if you compare also in the countries where this gate fee is lower, if you compare the value that biomethanol can have, because it is something that it is considered a carbon recycled fuel for RED II in Europe, this means that you can sell this product at a very significant price, or at same price when you compare the energy content with biodiesel, because methanol can also be used for biodiesel. But I would like to add another important concept, that methanol coming from this scheme, according to RED II, for the 40% of the price can be considered advanced. Why advanced? Because in the Annex 9 of the RED II, there is written that if you generate something from a bio waste, the carbon is a bio waste derivation. This means that what you produce is advanced, and according to statistic considerations in RDF, 40% of the carbon contained inside is from bio derivation. And this means that 40% the product that you generate is considered advanced in Europe, and for the 60% is considered a carbon recycled fuel. And so this means that even though you have a lower gate fee, but you can still rely on interesting internal rate of return because of this mandate that you presented at the beginning of this presentation, where the advanced has to reach 3.5% in 2030. And so far, there is in Europe a significant shortage of advanced product. In the market, we don't find advanced biofuels. This means that there is room for these products, and there is much more convenience to produce this advanced biomethanol instead of incinerating the waste with the old procedures.
Thanks, Giacomo. The next question I'll direct to Victor, because I believe when you guys announced that your biomethanol production was coming online, you would be supplying it to a biodiesel producer within Sweden. And the question is, there is environmental value for of producing methanol from biosources, but the CO2 that was once captured in that particular feedstock or waste is now emitted in the air after it goes through combustion in the ICE of a car. So what is the benefit of using biomethanol as a fuel? And beyond that, what is your view on the long-term viability of biomethanol as a land transport fuel?
Our view on that is that there needs to be a lot of different solutions to be able to make this kind of transitions. That there will not be one source and one fuel that can solve the whole problem. But of course, we believe that utilizing the current process instead of burning it as energy at the pulp mill, we can pull it out and create a more valuable product out there. So there needs to be a lot of different solutions and a lot of different fuels out there. But we believe in the biomethanol definitely as a part of the solution.
Thank you. And next question. Giacomo, I think this should be directed at you. When is the Livorno plant going to come online? I think that's the question down here.
I said that we started the Schedule A process that will be completed by this summer, and then it is expected 3 years to complete the unit.
Sure. And I'm sorry, Victor, just give me 1 second with one more question. There is a question here about sorting waste before it's being used as a feedstock in Livorno. How is waste separated or treated or sorted beforehand before it's used or gasified in your plant?
Sorry, I was something. Can you repeat?
Sure. My question was, or the question from the audience was, how is waste separated before? How is waste separated before it's gasified in your biomethanol plant?
What do we have to separate? The feedstock. Are you referring to the feedstock, Tim?
Yes, the feedstock. Is it sorted or it's processed?
The feedstock is the conventional process. It is sorted the feedstock, the case that we assumed, RDF, and then the RDF without any treatment is sent directly to the gasifier. It is just triturated, is mixed and then we achieve particles of the size of 10 centimeters, and then it is sent directly without any treatment in the gasifier. And so no treatment in advance for rebornification.
Thank you. So the next question to Victor is, or actually, Giacomo, you could feel free to jump in also, but I'll post this to Victor first. I believe there is a big segment in the audience that comes from the marine sector, because methanol has been touted to be a future fuel that is compliant with carbon reduction goals at the IMO. And the question is, the marine bunker market is 300 to 350 million metric tons per annum. What are your views on whether there will be production worldwide to cover the marine market if there was a decision to switch to methanol?
Yeah, that's a good question, and I read yesterday that there will be a cooperation now between Maersk, SAS, and DFDS and DSV. So exactly as you said, there is an interest in methanol and biomethanol. What we believe is that there are many pulp mills out there, and there is technology now to produce biomethanol from residue flow at the pulp mills, and of course there are other ways as well where you can capture CO2 and make electrofuels from it. So of course it's limited, but the market will definitely grow out there with renewable and biomethanol. Definitely.
Giacomo, what are your views on this? 300 to 350 million metric tons that the marine market might demand. Is biomethanol going to be able to scale up its production capacity in the future to at least capture a portion of this market?
I think that first of and so if you don't solve waste, look at the total waste quantity. But the other important concept that probably in the future the CO2 reduction passes through different actions, and so biomethanol can be one of the solutions. In the marine fuels, I see also the use of LNG. I see also use of some biofuels. I see also use of some part of the diesel. So I think that we can also imagine in the marine bunker, we can imagine also ammonia as a part of the utilization for electric marine ships. And so I think that methanol can play an important role, in particular if you select the route of the waste.
Thanks. We do have time. No, actually, we're almost out of time. So what I'm going to do is I'm going to wrap up this webinar with one more question. For those who have posted your question, but we have not answered it, do feel free to reach out to us. Our contact will be shared after. So the last question I'll ask, and this will be to the both of you, is how do the economics in terms of CAPEX and OPEX, feedstock prices, and production compare between biomethanol and conventional methanol?
I missed the question. There is probably there are interferences. Sorry, Tim.
Sorry. Sure. I'll repeat this once more. Yeah. The question is, how do the economics compare between biomethanol and conventional methanol in terms of CAPEX, OPEX, feedstock prices, or in general, production costs? How does it compare right now, and what are your views on how it might compare as we go into the future?
Look, Tim, I think that the simple and the cheapest way to produce methanol today in the world is starting from natural gas, and you achieve methanol. But of course, this means that you have to put in the atmosphere a lot of CO2. The real question is how much is the cost that you have to pay to continue use the planet as a sort of the waste to allocate the CO2. And so I think that the regulations like RED II, let me say, or the value of the CO2 carbon tax in the future that is expected to become higher and higher will make this process much more convenient than conventional ones. I think that if we want to change something in the world, we have to consider the CO2 no longer free of charge. CO2 has a cost in terms of the climate change, and if we would like to decarbonize the planet, we have to follow and to incentivize this type of technologies that are characterized by a lower carbon footprint. In order to do this, this means that you have to increase the cost of carbon dioxide emissions. That it is the real point. Once you have you do this, but at least in Europe, the European Union is ready to proceed with this in this way. I also looked at the projection of the cost of the CO2 based formed by International Energy Agency, and so they imagine to have the cost of the CO2  3 times, 4 times more than the actual cost. In such a way, of course, the old processes will become out of the market, because no sense to proceed in the old way. But sure. I think that we have to imagine this gradual transition. Now we are in this energy transition period, but in this period we have already to create the conditions for the future. But in particular, I would like to stress the concept, when you have renewable sources like waste, I think that waste today, it is a time to make use of the circular economy principles, and then to valorize the carbon and the hydrogen contained inside. Not only for the methanol, but you can use for methanol, but let me say for ethanol, for chemical products like acetic acids, etc. But we have to make, let me say, the old incineration system out of the market, in my view.
Victor, thanks, Giacomo. Victor, do you want to add anything to that before we conclude this session? What is your thoughts on the future production of biomethanol?
We don't hear.
Sorry, Victor, I think you need to unmute yourself. Okay, I think we are unable to hear him, but we would like to wrap up today's session. As mentioned earlier, you can find the handouts in the drop-down menu on your panel, on your control panel for GoToWebinar. Just click on the drop-down, you'll be able to download all the slides. I am sorry that we're not able to go through all the questions that we have, that we've received today, but we will try to go through with them, or at least give you a reply post-webinar, maybe through email. Feel free to reach out to us. Our contact details should be included in the slide if you're downloading it, and we can be reached through email. So thank you once again from Methanol Institute, NextChem, and Södra. Thank you for joining our webinar. We hope it's been helpful. And just to remind you, this is a first webinar in a series of webinars that Methanol Institute is going to organize. So stay tuned for the next webinar. And we look forward to receiving all of you again. Thank you.